Welcome back. This is an Aleks study video on writing net ionic equations. If you get net pay, it's what you have after you pay taxes. It's the stuff left over after everything cancels out that you don't have, that's not yours. So a net equation is anything that actually is left over to make something with. What you're going to see is not everything that's in the water or in the test tube is actually contributing to the product. Some stuff are going to be in the water that's not in the product, that's just kind of a leftovers, and we're going to ignore that in a net equation. So let me show you what I'm talking about, and maybe just seeing it may help you better. Anytime you have aqueous comes from the word water. So you're going to dissolve an ionic bond. That's an ionic compound. This is an ionic compound. This is an ionic compound. And you're going to dissolve these into ions. When it dissolves, it dissipates, it breaks apart dissociates into positive and negative ions. Well, in the water, you're never going to have magnesium nitrate. You're only going to have magnesium protons and nitrate ions. That's all. So we're going to show that, and then whatever is not participating in the product is going to not count. Now, what are we making here? We're putting stuff in the test tube. You're putting some more stuff in the test tube, and you're making some solid. This is your product. This is what you're actually making. This is still broken apart in the water in the test tube. So this is actually what's being made. So what we're actually using to make it is some magnesium and some hydroxide. Everything else is going to not participate in the production. All right, so I'll show you how that works. Let's write it out as ions. First of all, we know that nitrate is -1. We know that magnesium is in group 2, so it's +2. So first of all, I'm going to write magnesium as +2, because that's what's going to happen. Now, aqueous simply means it's in the water. So magnesium 2+ is in the water. What else is in the water? Nitrate. Now, nitrate doesn't break apart. It stays as a polyatomic ion, and there are 2 of them. When it completely breaks apart, there's 2 nitrates. Now, check this out. I have to use a coefficient now because the 2 means it's part of a compound. It's no longer part of a compound. It's broken apart. So I've got 2 NO3s, and NO3 nitrate is -1. Okay, so I have 2 -1s and 1 +2. Just like you did when you put it together, now it's broken apart. Well, those are floating around in the water. What else is in the water? I've got 2 sodiums. 2 sodiums, remember sodium is Na+, it's in group 1. I've got 2 hydroxides. Hydroxide is -1. So I have all of these ions floating around in the water. Now, if they break apart, and if they join back together, they'll just break apart again. If these 2 break apart in water, then anytime they would come to get back together again, they'll break apart again. But it happens that magnesium and hydroxide, if they were to come together, would not break apart again because it would form a solid that's not dissolvable in water, not soluble. And so it's the product. So if your hydroxide bumps into your magnesium, okay, and they're all floating in the water, they can do this. If it bumps into the magnesium, then it's not going to break apart again. It's going to make a solid and fall to the bottom of the test tube. And that is your product. All right, let's go over here. At the end, you're going to have magnesium hydroxide. Now, you don't break it apart because it's solid. It's not ions anymore. It's solid. It stays. It doesn't break apart in the water. It's not soluble. Okay, so I'm going to put solid here. I need to put aqueous here. That's the reason why we do all these aqueous, is because it's in the water. It's soluble in the water. This is solid, insoluble, but this is soluble. Aqueous means soluble. So what do I have over here? I've got 2 sodiums, and I've got 2 nitrates. Okay. Now, spectator ions. A spectator ion is anything that is an ion on both sides of the reaction. All right, so I'm looking for something that's on the same side, or on both sides, that are the same on both sides. Let me write aqueous, aqueous, aqueous. So I've got 2 nitrates here and 2 nitrates here. Let me do it in red. Okay, 2 nitrates here, 2 nitrates here. What else do I have that's on both sides that are not participating in anything? I've got 2 sodiums. I've got 2 sodiums. Everything else is in the net reaction. Everything else is participating in the product. So I've got magnesium, it's in the product. I've got hydroxide, it's in the product. So I'm going to write whatever's left over that is not spectator. These are spectator ions called. It's going to be magnesium 2 plus aqueous plus 2 OH minus aqueous, 2 hydroxides, yields magnesium hydroxide solid. And that is the net ionic equation. So write the net ionic equation for the reaction. That is the net ionic equation. It's whatever's left over when you take everything that doesn't participate in the product. So you may have to watch this a couple times. Hope it helps you.